Today we are going to discuss about hydrostatic forces. What is the definition of hydrostatic force? If the fluid is at rest, the corresponding force acting on the immersed surface is known as hydrostatic force. If the fluid is at rest, no relative velocity between the two adjacent layers. That is, this is the channel, this is one fluid layer, this is the another fluid layer. There is no, if the fluid is at rest, there is no relative velocity between the two adjacent layers. And another point, the rate of change of velocity or velocity gradient means the change of velocity between the two adjacent layers divided by depth between the two adjacent layers. But here in this case, change in velocity between, there is no velocity, automatically change in velocity between two layers is equal to 0. Therefore, du by dy is equal to 0. Right? Once the du by dy is equal to 0, shear stress, we know one shear stress formula, tau is equal to mu into du by dy. But in this case, there is no change in velocity, there is no velocity, there is no movement. The fluid is at static condition, therefore there is no du by dy. Du by dy is equal to 0, therefore shear stress is also 0. Okay. So if the fluids are at rest stage, there is no change in velocity, there is no velocity gradient. Once there is no velocity gradient, shear stress is equal to mu into du by dy. Du by dy is equal to 0, therefore shear stress is also 0. So that the forces acting on the immersed body, if the fluids are at static, are only two forces, that is pressure force because of the pressure intensity normal to the surface, and another one is the self weight of the fluid, that is because of the gravity. Only two forces acting if the fluids are at rest condition, one is pressure force, another one is the self weight of the fluid particle. Right? The determination of these forces are very important in the design of storage tanks, ships, dams, and other hydraulic structures. Definition of total pressure and center of pressure. Total pressure is defined as the force exerted by the static fluid on these immersed surfaces. That surfaces may be inclined or plane. When the fluid is contact with the surface and the force exerted is normal to the surface. And another one, the center of pressure. What is center of pressure? Center of pressure is defined as the point of application of total pressure is known as center of pressure. Right now, the total pressure and center of pressure on the immersed surfaces are as follows. One is horizontal immersed surfaces, vertical immersed surfaces, inclined immersed surfaces, and curved surfaces. Horizontal immersed surfaces. Now we are going to take one plane surface that is immersed in water in horizontal. Suppose this is one surface, plane surface that is immersed in liquid like this. This is the horizontal position. So if this is immersed in the static fluid, what is the total pressure? What is the center of pressure? Total pressure force, total pressure equal to W A H bar. W is the unit weight of water, or this is also nothing but rho g into A into H bar. Rho equal to mass density of the liquid, g equal to acceleration due to gravity, A is the surface area. This is the one plane surface immersed in water horizontally. This is the surface area. And H is the distance between the centroid of this plane surface up to the free surface. Right, this is nothing but H bar. H bar is the distance between the centroid of this plane area up to the free surface. Right, the total pressure equal to rho g a H bar. This is the formula for the determination of total pressure if the plane surface is immersed in liquid is horizontally. Right, another one, that is equal to W is equal to specific weight of the fluid, or rho equal density of the fluid, g is equal to acceleration due to gravity, a is equal to cross sectional area, h is the distance between the centroid of this plane surface up to the surface level. And next point, what is the center of pressure? Here center of pressure is nothing but point of application of resultant force. So if the thickness of this plane surface is very very small, this is immersed in the horizontally, therefore h bar is the cg to the free surface equal to h star is nothing but the center of pressure. Center of pressure is denoted by h star. In case of plane surface is immersed in liquid, in static liquid horizontally, h bar is equal to h star. That means the center of gravity is equal to center of pressure. Right? Thank you. Next class we will discuss about remaining. Today we are going to discuss about derivations related to fluid is at static condition, a plane surface immersed in vertically in the liquid. Right. Vertically immersed surface submerged in liquid. Now we are going to derive the expression for total pressure and center of pressure if the plane surface is immersed vertically in the static liquid. Right? Consider a plane vertical surface of arbitrary shape immersed in liquid. This is the figure. Now this is free surface of liquid. In the free surface of liquid, a plane surface is immersed vertically. That means this is the plane surface. That plane surface is immersed vertically in the liquid like this. In this case, this is the surface area of the plane surface. Right? Okay, now here vertically immersed plane surface. Here this is the vertically immersed plane surface. This is the arbitrary shape. Okay. Here this is the point G. G is the center of gravity of the plane surface. P is the point of center of pressure. The CG or G of the plane surface is h bar distance from this free surface. H bar is the distance between the CG of the plane surface to the free surface. This is known as h bar. And h star is the distance between the point of application of total pressure or center of pressure to the free surface. This is the h star. And the surface area of this element is capital A. Capital A is the total area of the vertical immersed surface. H bar is the distance of CG of the area from the free surface of liquid. G is the center of gravity of the plane surface. H star is the distance of center of pressure from the free surface of the liquid. Right? Right. Now we are going to determine the total pressure. First we are going to determine total pressure. Next we are going to determine the center of pressure. Total pressure. Right. The total pressure on the free surface may be determined by dividing the entire surface into number of small strips. Right? The total pressure over the surface is determined. The entire surface, the entire plane surface is divided into number of small strips. Then we are going to determine the force on one strip, that is the strip depth is, say dh is the strip depth, and that h is the distance of the free surface of the liquid to the top point of the strip. Right? First we are going to determine the pressure on the strip. Then we are going to determine the total pressure force on the entire area. That is estimated the integration of pressure force on the small strip. Integration of pressure force on the small strip, then we have the total pressure force on the entire strip. Right? The force on small strip is then calculated, and the total pressure force on the whole area is calculated by integrating the force on the small strip. Consider a small strip. This is the dh is the small strip. The depth of the small strip is dh. That is h distance from the free surface. Right. Now, For the determination of total pressure, first we are going to determine what is the intensity of pressure, then what is the pressure force on the strip, then what is the total pressure force on the entire plane surface. Like that we are going to determine step by step. First one, intensity of pressure on the strip. Intensity of pressure on the strip equal to, pressure is equal to stress into area. Intensity of pressure is equal to, what is the formula? W into H. That is, W is the unit weight of liquid into H is the distance from the free surface to the strip. Or this is equal to rho G into H. This is the intensity of pressure over the strip. Now, the total pressure force on the strip, that is dF. Pressure force on the strip equal to, pressure force equal to, force equal to stress into area, or intensity of pressure into area. Intensity of pressure already we have determined here. Therefore, intensity of pressure P into area, this is equal to intensity of pressure already determined, rho GH into what is the area? Area of the strip is, this is the depth of the strip is dH into width of the strip is B. Therefore, area is equal to B into dH. Therefore, area is equal to B into dH. This is the force on the strip. Now we are going to determine the force on entire surface, entire plane surface. Now the force on the entire plane surface is determined. The force on the strip is integrate the force on the strip, then we have the force on the entire strip. Therefore, force on the entire strip, force on the entire plane surface is equal to, force on the entire plane surface is equal to integration of force on the small strip, that is equal to rho G H into B into dH. Right? Now, force on the entire strip, force on the whole area, force on the whole plane surface is equal to integral rho G H into B dH. Rho G is constant taken out, then H into B dH. Right? This is equal to rho G. B dH is nothing but integral H dA. dH is nothing but area of the strip, that is dA, right? Area of the strip. Right? Now we know one statement, that is integral H dA is the movement of surface area about the free surface of liquid. This integral H dA is the movement of surface area about free surface of liquid. Therefore, movement of surface area means distance, area into distance from the free surface. What is the area of the entire plane surface? Area into the CG of the area is equal to, this is the CG, this is entire area into, this is the CG. Automatically the distance from the free surface is H bar into H bar. Are you clear? Integral H dA is the movement of surface area about the free surface of liquid. Therefore, movement of surface area means area into distance from the free surface, that is into H bar. Right? Therefore, total pressure force in place of integral H dA, we are going to substitute the AH bar. Therefore, pressure force F is equal to, total pressure force F is equal to rho G into, in place of integral H dA, we are going to take AH bar. This is the formula for the determination of total pressure on the plane surface, vertically immersed surface. Okay? Right. Okay, clear? Now, finally, the pressure force, the total pressure force, the total pressure on the entire surface F is equal to rho G A H bar, or rho G is also nothing but unit weight. F is equal to W A H bar. Here W is the unit weight of water, A is the plane surface area, h bar is the distance between the CG of the plane surface to the free surface, right? This is about total pressure. Now we are going to determine the center of pressure. Center of pressure is calculated by using the principle of moments. It states that movement of the resultant force equal to the sum of the moments of components. Center of pressure is calculated using the principle of moments. It states that moment of resultant force about the axis is equal to sum of the moments of the components about the same axis. Therefore here this is the point P. The resultant force F is acting at P. The resultant force F is acting at P. That is known as center of pressure. What is the definition of center of pressure? The point of application of total pressure is known as center of pressure. Now the total force acting at point P. Therefore, this is the distance. H star is the distance between the center of the pressure to the free surface, right? The resultant of force F is acting at P at a distance h star from the free surface of liquid, right? Now, hence the momentum of the force about the free surface of liquid. Momentum of the force, that is the resultant force. Momentum of the resultant force about the free surface of liquid equal to momentum means distance into force. The total force is F into distance is, that is nothing but that the distance between the center of pressure, point of center of pressure to the free surface. That is H star. Right? This is the first point is over. Next point. Now we are going to determine the moment of force dF acting on the strip. That is moment of force acting on the strip, that is equal to moment of force acting on the strip is equal to dF. What is the moment? Is equal to what is the force? Force on the strip is equal to, already I have given pressure intensity into area. What is the pressure intensity? P rho G H is the pressure intensity into area B into dH. This is the force on the small strip. Movement means into H, that is the distance between the strip to the free surface, right? This is the rho G H into B dH into H. Okay, now this is the moment of force on dF acting on the strip. Now sum of the moments of all such forces, that is equal to integral dF into distance H. This is equal to integral rho G H into B dH into H. Now rho G is taken out. Rho G is taken out from the integral. That is equal to B dH into H. This is equal to rho G integral H square into B dH is nothing but dA, right? Moment of sum of the moments of all such forces. Sum of the moments of all such forces about the axis is equal to rho G integral H square into dA. But we know integral H square dA is the moment of inertia about the surface area. Moment of inertia of the surface area about the free surface of liquid, right? Integral H square dA is the moment of inertia of the surface about the free surface of liquid. Therefore, this is known as I0, moment of inertia about the free surface of liquid. This is denoted by I0. Therefore, sum of the moments is equal to rho G. In place of integral H square dA, we are going to take I0. This is equation number 2. Now equating the moment of resultant force about the axis and sum of the moments of components of about the axis is, now equating these two, moment of resultant force is equal to F into H star equal to sum of the moments of all such forces about the free surface of the liquid. Right, F into H star is equal to, now we have determined sum of the moments of all such forces about the free surface, that is equal to rho g into I0. This is the moment of inertia about the surface, moment of inertia of the surface about the free surface of liquid. Now, but F is equal to, already I have given total pressure force, total pressure equal to rho g a h bar, that is already we have derived. In place of total force, in place of resultant force, we are going to substitute this value. Therefore, rho g a h bar into h star is equal to rho g into I0. Rho cancel, g cancel. Therefore, h star is equal to I0 divided by a h bar. But we know one statement, that is, but by the theorem of parallel axis, from the theorem of parallel axis, I0 is equal to Ig plus a h bar. From the theorem of parallel axis or parallel axis theorem, I0 is equal to Ig plus a h bar. Ig is the moment of inertia about the CG, moment of inertia about CG parallel to the free surface. Right? Now in place of I0, that is equal to Ig plus a h bar divided by a h bar square. I0 is equal to, based on the parallel axis theorem, I0 is equal to Ig plus a h bar. I0 is the moment of inertia of the surface about the free surface of the liquid. Ig is the moment of inertia about the CG of the surface. Right? A h bar. Now this is equal to h star, that is the center of pressure, the distance of center of pressure from the free surface is equal to Ig divided by a h bar plus a h bar square divided by a h bar. Square, h bar get cancel, a cancel. Therefore, h star is equal to Ig divided by a h bar plus h bar. This is the formula for the determination of center of pressure. Center of pressure h star is equal to Ig divided by a h bar plus h bar, where Ig is the moment of inertia about CG, h bar is the distance between the centroid of the plane surface to the free surface, a is the surface area of the vertically immersed body. Right? This is the formula for the determination of center of pressure. Now it is observed that this is the equation we have. This is the equation we have. Already we know h bar is the distance between the centroid of the plane surface to the free surface. H star is the distance between the center of pressure, point of application of total pressure, to the free surface. Right? This is h star. This is h bar. Therefore, the center of pressure lies below the center of gravity. We learn one point here, the center of pressure is always below the center of gravity. H star is always more than the h bar. That is the point number 1. And another point, based on this equation, center of pressure is equal to Ig divided by a h bar plus h bar. The center of pressure is not depends on the density of the fluid. Not depends on the density of the fluid. These 2 points we are going to remember. Right? Now we are going to discuss about inclined plane surface submerged in liquid. Right? Now the expression for total pressure and center of pressure for inclined plane surface submerged in liquid. Now let us consider a plane surface of arbitrary shape immersed in liquid. This derivation also as like as earlier case, but only the difference is the plane surface submerged. Suppose Earlier case, the plane surface is submerged like this vertically. Now, instead of vertically, the plane surface is submerged like this, some angle. Earlier, this is the 90 degrees angle with the free surface. Now, the plane surface is submerged like this. This is 90 degrees with the plane surface. Now, this is some theta. That plane surface is immersed in the liquid like this. That angle is theta. That is only the difference here. The surface is inclined. Right, let us consider the plane surface arbitrary shape immersed in liquid in such a way that plane surface makes an angle of theta. This is the plane surface makes an angle of theta with the free surface of the liquid. Right? Only the difference is earlier case, this is the plane liquid, this is the liquid surface, this is the arbitrary shape. Please listen. So here, this is the CG of the plane surface. Now this is denoted by H bar. Now this is the point of application of total pressure. This is denoted by H star, that is the center of pressure. We have taken one small strip like this. The distance from the small strip to the free surface is taken as H. If the plane surface is immersed vertically in the static fluid. But now this is the different. The plane surface is immersed in liquid in such a way that that makes an angle theta with the free surface. Now we are going to take one axis, that is 0, 0, 0, 0 is the one axis. Suppose this is the plane surface. Initially we have submerged like this. Now we have submerged like this. Now say this is the 0, 0, point 0, 0 to point 0, 0. This is the strip. Earlier case with respect to free surface. Suppose now we are going to assume that this is the with respect to free surface. Instead of free surface, we have taken 0, 0. Okay. Now this is the strip we are going to take. The depth is equal to dh. That is y distance from the 0, 0, and this is the CG of the liquid, that is y bar distance from the 0, 0. This is the center of pressure, that is y star distance from the 0, 0. These are the differences as compared with the earlier one. Earlier case we have directly have H bar, H star, but now we are not directly have the H and H star and H bar. But based on this figure, we are going to develop the H star, H bar and H. Right? This is a diagram here. Let us consider the following data from the above figure. From that figure, A equal to total area of the inclined surface. This is the total area of the inclined surface is capital A. H bar is the height of center of gravity of the inclined area from the free surface. This is H bar. H star is the distance of center of pressure from free surface of liquid. This is the center of pressure. So this is the H star is the distance between the point of center of pressure to the free surface. Right? These are the terms, and also theta is angle made by the inclined plane surface with the free surface of the liquid. Theta is angle made by the inclined plane surface with the free surface of the liquid. This is theta. Right? 0, 0 is the axis perpendicular to the plane of surface. This is the plane of surface. Perpendicular to the plane of surface. 0, 0 is the axis. Please listen carefully. Right, next point. Let y bar is equal to distance of CG of the inclined surface from 0, 0. From 0, 0, this is y bar. Y bar is the distance from 0, 0 to CG. Next, y star is the distance of center of pressure from 0, 0. This is the distance of center of pressure. This is y star. Next one, y is the distance from, this is the free strip. As like as earlier case, we are going to take the one small strip. that is y distance from the 0 0, right? The strip depth is equal to area is equal to dA, depth is equal to dy. Dy is the depth, right? Now from this one, sin theta equal to sin theta, suppose we are going to take this one and this one, right? This is equal to h bar, this is theta, this distance is nothing but y bar. Okay, now sin theta equal to opposite side h bar divided by hypotenuse, that is y bar. Okay, please remember these points are very very important. Another one, again, now we are going to take this point, this is this point and this point. This is nothing but h star and this is nothing but y star. Here also sin theta equal to opposite side h star divided by hypotenuse, that is equal to y star. Like that, sin theta equal to this is the y, now this is h. Okay, sin theta is equal to opposite side h divided by y. These 3 points are different as compared with the earlier derivation. Sin theta equal to h by y, sin theta is equal to h bar by y bar, sin theta is equal to h star by y star, right? Now this is the equation. Now h is equal to y sin theta, h bar is equal to y bar sin theta, h star is equal to y star sin theta. These points we are going to remember, right? Next one, same steps. First we are going to determine the total pressure if the plane surface immersed in liquid in such a way that makes with an angle theta with the free surface. Now pressure intensity, same steps what we have followed in the earlier case, same steps here also we are going to follow. That is equal to pressure intensity equal to W into H, weight, unit weight into H, that is equal to unit weight is also nothing but rho g into H. But here H is also nothing but what? H is equal to, if the surface makes an angle theta, therefore H is nothing but rho g y sin theta. This is the pressure intensity over the strip. This is the pressure intensity. P is equal to rho g h. Rho g h, h is nothing but y sin theta. Already I have explained in the earlier slide. Right. Right, rho g sin theta. Now the pressure force on the strip, dF is equal to, pressure force equal to stress into area, intensity of pressure into area. This is equal to intensity of pressure rho g y sin theta into area is nothing but to B dH. Right, now this is the pressure force on the strip. Now the pressure force on the entire plane surface, the pressure force on the total surface, that is equal to F is equal to integral rho g y sin theta into B dH. Now rho g sin theta taken out, therefore F is equal to rho g sin theta integral y b dH. Right, now this is equal to, now already integral y b dH is also nothing but, integral y b dH is the moment of area about the axis OO, moment of area about the axis OO, because this is y not h. Integral y bh is the moment of area about the axis OO. Therefore this is also nothing but area, moment of area into about the axis y bar. Right, y bar. Therefore force is equal to, therefore force rho g sin theta into, in this place, integral y b dh. This is also written as, integral y dA. Y dA is the moment of area about the axis OO. Therefore in this place area into y bar, right, into a y bar. Right, now rho g sin theta a y bar, but here y bar is also nothing but already I have given. Y bar is equal to what? H bar is equal to y bar sin theta. Y bar is equal to h bar divided by sin theta. H bar divided by sin theta. In place of y bar, h bar divided by sin theta. F is equal to rho g sin theta into a. In place of y bar, we are going to take h bar by sin theta. H bar by sin theta. Sin theta gets cancelled. Therefore, force F is equal to rho g a h bar. Right, this is the total force acting on the plane surface that is immersed at an angle theta with the free surface is equal to, F is equal to rho g a h bar, or F is equal to W A h bar, where W is the unit weight of water, A is the surface area of the plane, h bar is the distance between the center of the, this is the center of the objective to the free surface, that is distance h bar. Right, now we are going to determine the center of pressure. The center of pressure is determined by using the principle of moments. It states that the moment of resultant force is equal to the sum of the moment of the components at the same axis. Right, now the resultant force F acting at P at a distance h star from the free surface of the liquid. Right, this is the diagram already I have explained regarding this diagram. Now moment of the force F about OO, moment of the force about OO is equal to F into y star, because this is the make an angle with the theta. Therefore F into y star, F is the resultant force, y star is the distance of the center of pressure to the axis OO or to the surface OO. Moment of the force acting on the strip, that is equal to dF into distance dF into y. Right, already force dF is equal to, already I have given rho g y sin theta into, this is the stress, sin theta into b dy. This is already I have given force on the strip, dF is equal to rho g y sin theta into b dy into y. Now sum of the moment of all such forces equal to sum of the moments of all such forces about OO is equal to integral rho g y sin theta into b dy into y. Therefore this is taken out, rho g sin theta taken out, then yb dy into y, and rho g sin theta integral y square into b dy is nothing but dA. But here integral y square dA is the moment of inertia about the surface, or moment of inertia about the axis OO. Moment of inertia about the axis OO, this can be written as integral y square into dA. This is nothing but moment of inertia about the axis OO. Therefore this is written as I0. The sum of the moments of all such forces is equal to rho g sin theta into, in place of y square dA we are going to take the I0. Right, now as per the principle of moments, we are going to equating the moment of resultant force must be equal to the sum of the moments of the components. Right, Now we are going to equating these two equations, that is equal to moment of the resultant force about the axis OO, that is equal to F into y star, that is equal to sum of the moments of all such forces, that is equal to rho g sin theta into I0. But here F is nothing but, already I have given, F is nothing but in place of F already total force we have determined, that is equal to rho g a y bar is equal to rho g sin theta I0. Rho g gets cancelled, and also a into y bar right here, right, into y star. F is equal to rho g a y bar, F is equal to rho g a y bar into y star, then a y bar into y star into sin theta I0. Y star is equal to, that is equal to I star is equal to sin theta I0 divided by a y bar. Y star is equal to sin theta I0 by a y bar. This is the equation we have. Y star is equal to rho g sin theta I0 divided by rho g a y bar. Rho g gets cancelled. Y star is equal to sin theta I0 by a y bar. But here y star is also nothing but y star is equal to h star divided by sin theta. H star divided by sin theta equal to sin theta into I0 divided by a y bar. Therefore h star is equal to sin square theta into I0 divided by a y. H star is equal to sin square theta I0 divided by a h bar. But as per the parallel axis theorem, I0 is equal to ICG plus a y bar. Right. Therefore, h star is equal to sin square theta into I0 ICG plus a y bar divided by a y bar. In place of y, we are going to take y bar is equal to h bar by sin theta. In place of this, we are going to take h star is equal to sin square theta into Ig plus sin square theta into a into, in place of this we are going to take y bar, h bar divided by sin square theta, because this is square, h square sin square, this gets cancelled, divided by a y bar. Therefore h star is equal to sin square Ig divided by a h bar plus h bar. From this equation finally we have h star is equal to sin square Ig divided by a h bar plus h bar. Right? This is the equation we are going to use for determination of total center of pressure in case of plane surface immersed in at an angle theta with the horizontal. Right? Thank you, one and all.